this problem is for you to try. I'm going to give you a little bit of strategy. If you don't want the strategy, you can go ahead and pause the video now. If you do want strategy, you'll notice that we know sides A and B and angle C. So I don't have a pair of an angle and the opposite side. Okay. I'm going to just draw myself a picture. And it's probably not going to be the least bit accurate. I don't know whether I have an acute triangle or not. I just want a place to put things. So C is 32.1 degrees. Clearly I did not draw to scale. Side A is 4.7 meters and side B is 1.2 meters. Okay, so I'm going to need to use law of cosines first because I can't use law of sines. I don't know an angle and the opposite side. So the first thing I'm going to do is find side C using law of cosines. Now once I have that, then I'm going to have a pair of an angle and the opposite side. So now I could continue with law of cosines, but law of sines is a lot simpler, so I probably want to do that. But I need to be careful because there's no way C is the biggest angle that I have here because the other two have to add up to almost 150 degrees in order for the whole thing to add up to 180 degrees. So my biggest angle is actually going to be angle A because I can see it's got to be bigger than angle B because it's opposite the bigger side. So if I have an obtuse angle, it's A. I don't know if I do or not, but I know that B is not the biggest angle, therefore B is acute. So I'm going to find B using law of sines. That's because I know it's acute, so once I know its sine, B is just arcsine of that value. With A, I wouldn't know if I knew the sine, whether it was the acute or the obtuse angle that had that sine. But once I've got B and C, then I can get A because they have to add up to 180 degrees. So then I can find A, and that's just by using the sum of the angles in a triangle. Okay, so that's our strategy. If you've listened for this long, go ahead and pause the video now and work this out. If you hadn't listened to this previously, but you did something differently, and you solved for angle A first, you might want to go back and redo the problem because even if you got the correct answer, you didn't justify it because you sort of flipped a coin about whether A was going to be acute or obtuse. Okay, see you in a moment. Okay, so I'm going to just write out the law of cosines for finding side C. So C squared is A squared plus B squared. It starts out looking just like Pythagoras, but because C was not an acute angle, I need to adjust. So minus 2 copies of AB times cosine of C. Okay, so C squared will equal, let's see, A was 4.7 squared plus B was 1.2 squared minus 2 times 4.7 times 1.2 times cosine of 32.1 degrees. Now, I was careful to continue writing that was C squared. I'm going to solve for that, then I'm going to have to take the square root. Okay, could have written that initially, but I think it's easier to just plug this in, get that answer, and then take the square root of that. All right, so 4.7 squared plus 1.2 squared minus 2 times 4.7 times 1.2 times cosine of 32.1. And if you haven't recently used your calculator to know that it's in degree mode, you might want to double check that you're in degree mode. Pretty much every time I'm typing trig into my calculator, I'm like, oh, did I check? Did I check? And I just did. So we're good to go on my calculator anyway. All right. So I get that C squared is 13.974, blah, 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 blah. I'm not going to round that because I want to take the square root of that. I'm going to take the square root and then round. Rounding should always be my last step. So C is I'm going to just hit square root and then use the answer key on my calculator. The other thing I could have done is while that was still on the screen, I could have raised it to the 0.5 power. That's another neat trick, remembering that the square root is a fractional exponent. So if you don't have an answer key, that's a way that you can avoid having to type in all of those digits. All right, so I'm getting 3.7382 blah, 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 which would be approximately 3.7. So side C is approximately 3.7 meters. Okay, so we've done step 1. Now we're ready to find angle B, which we know is an acute angle because it's not the biggest one. Okay, so let's see. I need some space here. I think I'm just going to erase the picture. Okay, so I can say that sine of C, actually, C was 32.1 degrees over C. Now here, I'm actually just writing C. That's because I've still got this stored in my calculator, and I'm going to use the non-rounded version. That's going to give me something that's a little bit more exact. Now, unfortunately, your book sets a bad example. They go ahead and round and then use the rounded value. So, if you do that, because the book sets a bad example, I'm not going to penalize you for following the book's example. So, it's preferable to use the non-rounded version in your calculations, but if you use the rounded version, I will not penalize you. That means you could be off from the answer that I provide by a digit or two, but I'll work it out both ways, and so I'll see if that's what you've done. Okay, this is going to equal, if we're finding angle B, that's going to be sine of B over 1.2. Okay, so let's solve for sine of B. Okay, so C times sine B is equal to 1.2 sine of 32.1 degrees, which means I can erase this work here. Sine of B is 1.2 times sine of 32.1 degrees divided by this number C. Okay. Now, since I've got that in my calculator already, okay, I'm not multiplying it by anything. I'm dividing by something by it. So all I'm going to do to get that on the bottom is just type in 1 divided by my answer. That's now taken the reciprocal of C, and now I'll hit times 1.2 times sine of 32.1, and I am still in degrees. Okay. All right, and so when I do that, I get sine of B is equal to 0.1705 blah, 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 blah. Okay, now, if you had used, instead of this non-rounded version, if you had used 3.7, you might be a little bit different in some of these later digits, but you should be in the same ballpark. Okay, and then B is going to be arcsine of 0.1705 blah, 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 blah. So I simply hit shift the sine key, my answer, and I've got 9.82 blah, 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 which would round, I'm rounding to the tenths place, that would round to 9.8 degrees. So angle B, I've got is about 9.8 degrees. And then finding angle A, I can do by simply using the fact that the angles in a triangle have to add up to 180 degrees. So A plus 32.1 degrees plus 9.8 degrees has to equal 180.0 degrees. Let's see, that's A plus, that's going to give me a 0.9, 11, 41.9 is 180.0. I'm going to subtract the 41.9. And so A is approximately 138.1 degrees. So it turns out it was an obtuse angle. So if we had tried to use law of sines and taken arc sine of the sine of A, it wouldn't have given us the right answer. Okay. In this case, it's not ambiguous. A must be that obtuse angle, but using law of sines, I don't see that. So I had to use law of sines to find the one that I knew was acute, and then I could see, because B and C didn't add up to 90 degrees between the two of them, A had to be extra big to compensate for how small they were.